Different from most pre-calculus classes, we're actually going to start our year with an introduction to sequences and series. Usually this is done at the end of the year, right before limits, because series and limits are what are really fundamental to learning calculus. However, I'm going to start the year with sequences and series, and if we need to, we can review at the end of the year or even next year if you decide to take calculus. So there's a reason for it. I'm not going to tell you what that reason is right now, but I'll tell you at the end. So first of all, what is a sequence? Well, here's a sequence, 1, 3, 5, 7, 9. Here's another one, 1, 3, 9, 27, 81. And here are non-sequences, 10, 45, 2, negative 6.8, 7, 2, 3, 3, 3, 3, 2, 4, 8, 347, negative 1. Those are non-sequences. So what do you think is a sequence? Go ahead, answer it. What's a sequence? No, really, pause and write in your notebook what you think it is. I'll be checking. So a sequence is a list of numbers that follow a certain pattern. There has to be a pattern to the numbers in order for it to be considered a sequence. We're going to look at a sequence by first looking at a family tree. So for those of you who know what a family tree is essentially a diagram of all of your family members. There are different kinds of family trees. So we're going to be looking at an ancestral family tree. We're only going to be looking at your direct ancestors, not cousins, no brothers, no uncles, just you and your direct ancestors. So we're also talking about your biological ancestors. Okay, if you were adopted by a single parent, for example, we're not talking about that. We're talking about your biological ancestors. Usually we have the older generations at the top and the youngest generation at the bottom. We're going to start with you. So you are going to be at the bottom, and then we're going to go up looking at the older generations. So hopefully we know the symbol for male and the symbol for female. We don't really care so much about that, but there it is. And again, we start with you at the bottom, and then we have your parents. Biologically, you had one male and one female parent, and then each of them had one male and one female parents, so that you have 4 grandparents. Each of them had 2 parents, so you have 8 great-grandparents. And you could keep doing this forever and ever and ever and ever. So here we go. Let's make a table of this. So if we have 3 parts to our table, the top being the number of generations back, the middle one will be what we call that generation, and then the number of people, the number of ancestors in that generation. So 0 generations back is just you. There's one of you. 1 generation back are your parents. There are 2 of them. 2 generation back, grandparents, there are 4 of them. 3 great-grandparents, there are 8. 4 generations back, there are 16 great-great-grandparents, 32 great-great-great-grandparents, 64 great-great-great-great-grandparents, and you could keep going if you wanted to, forever. So you can see that there's definitely a pattern in the number of ancestors. 1, 2, 4, 8, 16, 32, 64. You could even describe that pattern, and we're going to do that here when we learn about sequence notation. So for those of you who know what notation is, it's just a way of writing something. You've seen notation before. So in example, we have 4 squared, or 4 to the 2nd power. The 2 is written small and raised. That's the notation for an exponent. We know that it's an exponent because of the way it is written, because of the notation. So there's such a thing called sequence notation. We know something is in a sequence because we can write it as a sequence. Each number in a sequence is called a term. Each term has a term number saying how far from the beginning it is. Note that sometimes we start at term 0 and sometimes we start at term 1. Hopefully that will be clear. If it's not clear, then maybe it doesn't matter and you can start it however you want, as long as you're clear in your explanation. So here's an example. we have 4, 8, 12, 16, 20. Again, there's a clear pattern there. Hopefully you can describe that pattern. The first term is 4. The second term is 8. The fourth term is 16, etc. So we say, this is the notation now, the a with the little 1 that's written a little bit below it, so an exponent is written a little bit above and called superscript. And here in sequence notation, the term number is written in subscript, a little bit down. So we have a with a little 1 written a little bit down, and we pronounce that a sub 1. It's written in subscript. So a sub 1 is equal to 4. A sub 2 is equal to 8. A sub 4 is equal to 16. And that is sequence notation right there. So let's take this back to our example of the family tree. Here is our table. We have our pattern of numbers, 1, 2, 4, 8, 16. So a sub 0 is 1. Remember I said sometimes we'll start with a sub 1, sometimes we'll start with a sub 0. So a sub 0 is equal to 1, a sub 1 is equal to 2, a sub 2 is equal to 4, a sub 3 is equal to 8, and you can keep going. We want to come up with a sub n. A sub n is the general rule that describes this sequence. So in other words, n is that variable that you're familiar with. So if we wanted to know what a sub 100 was, we would make n 100, and our rule for the sequence would tell us what a sub 100 is. So here, go ahead and try to figure out what the rule might be. So the rule here is 2 to the nth power. How do I know? Well, let's look at it. A sub 0 is 2 to the 0 power. Hopefully we remember our exponent rules. Anything to the 0 power is 1. A sub 1 is 2 to the first power. 2 to the first power is 2. A sub 2 is 2 to the second power, which is 4. How did I know to go 2 to the second power? Because it's a sub 2, so n is 2. So it's 2 to the nth power. So n is 2, it's 2 to the second power. Same thing here. A sub 3 means n is 3. So we do 2 to the third power, and that gets us 8. 2 to the third power is 8. This is called a direct rule, or explicit rule. In a direct rule, also known as an explicit rule, you input the term number, and the output is the term value. So when you input 3, for example, as the term number, the output is 8, the value of that term number. So we can look at it again. Same idea, a sub 0 is 1. I'm just copying down the same stuff we just had. But this time we're going to come up with a different kind of rule. So for this rule, we need 2 parts to it. First, we need to know where to start. We're going to start with a sub 0 equals 1. And then a sub n is going to depend on that. So we can say, in order to find a sub n, in order to find any term, we look at a sub n minus 1. So we're looking at a sub n is equal to a sub n minus 1, which is the previous term, and then we multiply the previous term by 2. So again, we're starting with a sub 0 equals 1. How do I know that? Because that was given. It was given right here. A sub 0 equals 1. And then to figure out a sub 1, we take a sub n minus 1. So 1 minus 1 is 0. A sub 0. And we multiply it by 2. A sub 0 was 1 times 2 is 2. This can get confusing. Feel free to pause, rewind, try to make sense of what this says. A sub 2 is equal to a sub 1 times 2. A sub 1 was just 2, so we have 2 times 2, which is 4. A sub 3 is the same thing as the previous term times 2. The previous term, a sub 2, was 4, so 4 times 2 is 8. This is called a recursive rule. The input is the previous term value, and the output is the current term value. So I know that this might be a little confusing. No worries. We're going to look at this in class, and hopefully it'll make a little bit more sense to you then. Write down any questions. Write down all your notes, of course. Write down any questions you have so you can be prepared to ask them when we are in class tomorrow.